I welcome you all to the session of engine system and performance, and in continuation of my last lecture on this topic, that is on the engine system. Today we shall discuss about another two subsystems and their requirements in the context of engine performance. So, in the last lecture we have discussed about the ignition system, and we had seen that ignition system is very important for an engine, because ignition is necessary to initiate combustion. Not only that, in ignition system there are a few components which are responsible to initiate spark depending upon the requirement of the engine, and also the spark that will be produced by the spark plug has to be distributed uniformly inside the cylinder, so as to fuel air mixture or even fuel in a furthest location should be able to combust properly. So, today let us discuss about another important subsystem, to be precise, though I am referring to system because all these are subsystems. If we assume that engine is a system, rather mechanical system, then ignition, lubrication, cooling, all these are subsystems. So, today we shall discuss about the lubrication system. Now, we all know that you have studied even in your undergraduate course on this particular topic, that is internal combustion engine. When piston moves between these two locations that we have identified even in the previous lecture, that is bottom dead center and top dead center, the piston has or piston needs to have continuous movement between these two locations, that is the reciprocating movement or reciprocating motion. That reciprocating motion should be converted into rotary one using again some mechanical linkage or mechanical system. That is what you have learned in your undergraduate course, but what I would like to emphasize today, that when piston needs to move inside the engine cylinder, then you know that these two there are mating components. So, there is a relative motion between these two mating components, that is piston surface or outer surface of the piston and the cylinder wall. So, we need to minimize when there are two mating surface and there is a relative motion, we know that friction will be there. So, we need to reduce frictional effect, because otherwise whatever power that will produce inside the cylinder will be used to overcome that frictional losses. So, it would be kind of detrimental for an engine system, and not only that. So, the most important objective is to overcome the frictional losses, we need to supply lubricant, and since there is a relative motion between piston and the engine cylinder, so we also need to take care of several other issues like tear and wear. So, all these are mechanical problem. So, coolant, not only coolant, lubricants are provided to minimize the frictional losses, to reduce the possibility of having wear and tear. Not only that, the lubricant also acts like a coolant. So, if we write that lubrication system, so this lubrication system has a few primary objectives. What are those? As I told you, to reduce friction, to minimize wear and tear. Secondary objectives are also there. What are those? Secondary objectives are, as I told you, to provide some cooling effect, right. Second thing is acts as sealing, I will discuss this part, and also acts as a cleaning agent. So, all these are basically objectives, primary objectives and secondary objectives. Now, if we look at this particular box, we can see despite all these primary objectives, there are a few secondary objectives. So, to provide some cooling effect that I told you, that inside the engine cylinder, because of the combustion, temperature will be excessively high, though we should not allow temperature to reduce drastically, but still, as I discussed in the last lecture, cooling system is necessary to reduce certain amount of heat from the engine cylinder, essentially to prevent all mechanical components from their possible failure. So, this lubricant will provide some sort of cooling effect, acts as sealing. If we go back to the previous slide, you can see that this is the space where combustion will initiate, then the space between this cylinder wall and piston outer surface, if it is filled with lubricant, that does not allow that combustion product to leak through that passage and go into the further down. So, that way it acts as a sealing and also cleaning agent, because if there are some sort of debris formation or some sort of carbon deposition, all these will be washed away by this lubricant. So, it acts as a cooling agent. We have now understood the objective of the lubrication system, rather lubricants. So, can we really use anything as a lubricant for an engine system? So, essentially when we will be selecting any particular lubricant, we must be careful about their some aspects, chemical and physical aspects. So, if we now write here requirement for a good lubricants. So, this is very important to know for any designer of engine. So, you can see that lubricant will be supplied so that to minimize frictional losses, to prevent mechanical failure through the formation of wear and tear. So, the lubricant you can see that, as I told you, that lubricant will be supplied to the passage which is in between the piston outer surface and cylinder inner wall. So, and that lubricant will experience huge shear stress, because the piston will be having continuous movement. So, we really cannot arbitrarily select anything as a lubricant for the engine system. So, one such requirement is, I am writing, leave no carbon then should maintain liquid required or required film. If it does not maintain required film, then we will not be able to minimize the frictional losses. That you can relate this to the fluid mechanics that you have learned, that that sort of journal bearing. So, if there are two mating in between two mating surfaces, if one is having relative motion, then the thin film is allowed to have, so that it can prevent frictional losses as well as several other mechanical issues. Then certainly the most important is low cost, chemically stable, low cost and chemically stable. Just I am writing a few, you can get it all this from books. And then viscosity should ensure sufficient hydrodynamic lubrication. Okay. It won't be chemically stable, because because you can see that the lubricant needs to face huge temperature or high temperature. So, it should not be unstable chemically, it should not decompose, it should not dissociate, all these things, and also it should be physically stable. Chemical stability and physical stability, these two are interlinked. How? Because if it is chemically unstable, then certainly it will be physically unstable as well. Physically, we know that it should not lose its properties, and also it should not be volatile, all these things, and then that is stable under different temperature. Okay. And the very important point is high flash point. I hope you know the meaning of this. High flash point, it is very important for any lubricant, just to avoid flashing of oil vapor. Or lubricant vapor. And the last one is should contain no sulfur, no sulfur. So, all these are basically requirement for good lubricants. Having discussed this, let us now quickly revisit different types of lubricants. As of now, we know that it may be solid, lubricant may be semi solid, and it can be liquid. So, I can write just solid lubricant, semi solid lubricant, or liquid. So, what is solid lubricant? Sometimes we need to supply sort of powder just to avoid frictional losses. I can give you a practical example. Have you seen that indoor any carom board, you will find that sometimes you need to apply some powder on the top of the carom board just to minimize the frictional losses. So, this is that powder acts like a lubricant just to minimize the frictional losses. So, solid lubricant, but it cannot be used everywhere and always. What is semi solid? So, semi solid lubricants are also there if we are unable to retain liquid lubricant. In such a case, we need to have semi solid lubricant. A common example is grease. If you go to any motorbike shop, any bicycle shop, or even any 4-wheeler repair shop, you will find that mechanics are frequently using grease. This is a sort of semi solid lubricant, and this lubricant is frequently applied to minimize the frictional losses. But the most important and common type is the lubricant, that is liquid lubricant. So, if I talk about liquid lubricant, liquid lubricant typically several oils. Several oils are the example of liquid lubricant. So, you can understand solid lubricant cannot be used everywhere, semi solid lubricant can be used, but again it cannot be used everywhere. Sometimes we need to use semi solid lubricant if there is a problem associated with the retention of liquid lubricant. But in most of the cases we use, rather the most common type is liquid lubricant, and we use, and the examples are several oils. It can be vegetable oil, right, it can be animal oil, and finally it can be mineral oil. So, vegetable oil, animal oil or mineral oil, all these oils are or can be used as liquid lubricants. Now, there are a few problems associated with vegetable oil and animal oil. What are those problems? Problem is that animal oil is, or animal oils get oxidized very quickly. You understand by this time that lubricants are supposed to experience or expose, they are exposed to high temperature, and at that temperature there is a possibility that lubricants will be oxidized. So, animal oils are very susceptible to that particular undesirable phenomenon, that is they can get oxidized. Vegetable oils are also similar to that of animal oil, but they have little bit more stability in terms of oxidation is considered, but as compared to animal oils, vegetable oils are good lubricants. But the mineral oils are very commonly used for the lubricants. So, these are most widely used and lubricant obtained for petrochemical, and these are cheaper as well. Cheaper as well. Not only cheaper, they have high chemical stability. So, these are not only cheaper, but also have high chemical stability. So, all these are basically liquid lubricant. Now, question is, sometimes we need to add additives to the lubricants. So, why do we need to add additives to the lubricants? And if we add additives to the lubricants, what extra or additional features we will get? So, this aspect let us discuss now. So, basically if we talk about additives, so two questions I would like to discuss. Why do we need to add additives to the lubricants? Second question is, even if we add additives to the lubricants, what are the additional features we are going to get? So, all these things are important to know. So, basically additives are used to provide some additional properties. What are those? One is corrosion inhibitors. Number 2 is sometimes we add detergents as additives. So, the function is these detergents break sludges into finer particles, so that this can be taken away by the lubricants. And we also need to use, the most important is viscosity index improvers. Okay. So, you can understand the sole purpose of this is to retain desired level of viscosity at high temperature. See, I have written to retain desired level of viscosity, because it is not possible to maintain unique viscosity of lubricant, but it will maintain in between some values, so that even at high temperature viscosity will not, because you know that liquid viscosity reduces at high temperature, right. So, if viscosity drops, then that lubricant won't be able to maintain hydrodynamic lubrication. So, these viscosity index improvers are very important just to retain desired level of viscosity even at high temperature. So, these are the kind of types of lubricant we have discussed now. So, we have understood that lubricants are necessary, their requirements, then different types, and then finally additives. So, let us briefly discuss about types of lubrication system. Just I am writing the name, you can get it from any textbook on internal combustion engine. So, this is basically first is mist or charge type, second one is wet sump type. It has again 3 different subcategories. The first one is splash type, second one is fully pressure, that is fully pressurized system. So, this splash type and fully pressure system, these two are very important, and finally we have wet sump. So, accordingly we can have dry sump time. So, these are 3 different types of lubrication system. Okay. So, now we can discuss about another important system, that is the cooling system. So, if we go to discuss about cooling system, that is engine cooling. Engine cooling system. As I told you that we need to supply fuel and we need to have some arrangements to initiate combustion, so that the fuel being supplied to the engine will be able to combust properly in the presence of sufficient air, and if combustion takes place efficiently and properly, we can run engine economically, engine will be having high efficiency. And what is the combustion that I discussed in the last class? Though combustion is a very complex subject to understand, but you should understand that combustion is basically some sort of chemical reaction, and those chemical reactions are basically exothermic reaction, out of which we are getting some amount of energy in the form of heat, and that heat energy will be converted to another form of energy, that is work, using some system, and that is basically the engine system. So, when there is heat energy developed or generated inside the engine cylinder, it is very unlikely that we can convert that same amount of heat into equivalent amount of work. It is not possible, that you know from thermodynamical constraint. So, though it is not possible to utilize total amount of heat that will be produced out of this combustion, there must be a provision that certain amount of energy which is in the form of heat should be taken away. Otherwise, the mechanical system, mechanical components, the components which constitute together to form the entire engine system will be having high temperature, and that high temperature may lead to some sort of mechanical issues through the formation of thermal crack. So, that cooling system is very important, because some coolant should be supplied so that the coolant can take away, the coolant can reduce certain amount of temperature from the surfaces or hot surfaces. So, that is very important again for the engine. So, engine coolant system, cooling system, you can understand, rather you know very well from your undergraduate understanding of this particular course, that is internal combustion engine. There are three different types of cooling. First is air cooling, second is water cooling, and third is basically thermosiphon cooling. If it is air cooling, then we term as air cooled engine. If it is water cooling, we term as water cooled engine. Thermosiphon cooling and water cooling, that the coolant is same, but still some mechanical, that transportation or transport of that coolant from the sum into the engine, that arrangement somehow allows us to differentiate these two cooling system. Okay. So, now let us discuss about what is the air cooling engine. Air cooled air is available in plenty. So, when engine when any 4-wheelers or 2-wheeler moves, that forward movement of any 4-wheeler allows engine to intake certain amount of air, and if that air can be drawn into properly to the engine system, so that incoming air can be used as as a coolant, and that air after taking certain amount of heat from the engine can be exhausted from the engine into the ambience again. Certainly, you are going to have sort of air pollution, but this is the concept of air cooling. Whereas, for the water cooling, this water cooling is some sort of secondary cooling system, because water will be stored in a sum, and that water will be pumped from that sum into the engine, and while water is circulated through the engine, it will take away certain amount of heat, but that heated water or hot water again will come back to the sum. So, we cannot use that hot water again for further cooling. So, certainly there must be a secondary cooling system, and again we need to rely on this air cooling. So, the incoming air, because of the movement of the 4-wheeler which is moving forward, the air that will be sucked into the engine, that air can be used again further in a secondary circuit to reduce the temperature of water, which has come after taking certain amount of heat from the engine cylinder. So, this is water cooling, and thermosiphon cooling is, again I told you. So, basically coolant is same, but in water cooling you can understand, if water needs to be circulated from a sum into the engine system, then we need to have a pump, because without a pump we cannot circulate water. There is a possibility that we may have a natural circulation loop. In that case, the water sum or water tank must be situated at a higher level of the engine. So, that also creates some additional problems. In a thermosiphon cooling system, we can eliminate the need of a pump. So, you have studied, I guess, in your undergraduate course. So, briefly let us discuss about a few issues, maybe even for air cooling system or water cooling engine system, there are some again advantages and disadvantages. So, let us briefly write about all this. So, air cooling system, we need larger fan. So, larger fan will absorb large power. Number 3 is when large amount of air will be passing through the engine, it will create or produce audible noise. So, large volume of air, when that volume of air will pass through some system into the engine, it will create some audible noise. So, these are the disadvantages. Similarly, you can still have some advantages. So, what are those advantages? Number 1 is air cooled engine, engines operate satisfactorily both at hot and cold climates. Okay. Air cooled engine can work at high operating temperature. Okay. And if we consider the air cooling system, you can understand that we have no need of having any sump to store water. So, the system is little lighter. So, I can write system is lighter or less bulky than water cooled. So, these are the advantages. So, we have discussed about the advantages and disadvantages of air cooled engine. Now, let us look into the engine or water cooling system. So, the last is water cooling system. So, you know that what are the advantages? I mean, you can understand that so I am writing advantages. Even if we consider air as a coolant, it may not be possible to have uniform temperature distribution from the engine cylinder using that coolant, but water, if we can supply, if we can circulate water, we can have uniform temperature reduction from every half of the engine system. So, that is called greater temperature uniformity around the cylinder. So, number 1 is greater temperature uniformity. Around the cylinder. So, that means if we consider air cooled engine, maybe where air velocity will be more, that therein we can have less temperature, but in some part maybe the velocity of air is not that much. So, maybe we will not be able to reduce temperature drastically therein. So, I mean non-uniform temperature distribution will be there, but in case of water cooled system we can ensure that the temperature uniformity or temperature should be uniform around the cylinder. Number 2 is, you know, that even if we have power consumption, because for water cooled system we need to have sum, and from that sum we need to supply water using a pump to the engine, you know, cylinder or engine system. So, despite having a separate pump, the power consumption would be even less as compared to the air cooled engine, because for air cooled engine we need to have a larger fan. So, to operate or to drive that larger fan we need to have substantial amount of power consumption requirement. So, number 2 is power consumption is lesser, is less, rather I should write less than air cooled engine, even after having a separate pump which is needed to circulate water from the sum into the engine cylinder. Okay. Then third thing is that cooling water jacket. If you try to recall the schematic depiction that I showed you today, the presence of cooling water jacket will absorb some sort or some noise from the engine. So, that is again very important aspect. So, absorbs noise, that is very important, and unit is rigid and can be used for heavy duty work. So, these are the advantages. Despite having all these advantages, still if we use water cooled system, there are some disadvantages. So, let us quickly write all these. So, disadvantages. Number 1 is it is liquid. So, we really cannot trivially ignore the possibility of having leakage. So, there must be some joint, it is not possible to have straight connection. So, there must be 60° bend, 90° bend, 45° bend. So, through this joint there will be a possibility of, you know, leakage. So, that is called leakage through joints. Number 2 is care must be taken to avoid freezing of water. If we take water cooled engine in regions where temperature is below 4°C, the coolant will freeze. If it freezes, then again you can understand what will be the problem. So, entire line, entire sum will, you know, buckle. So, number 3 is more time is needed to warm up than air cooled engine. Then number 4 is the last point, very important point, boiling point limits maximum temperature of operation. Boiling point limits maximum temperature of operation. So, boiling point of liquid coolant. So, basically what we have discussed today, this liquid air cooled engine is also having some distinct advantages, also some disadvantages. Water cooled engine, we have listed down a few serious advantages, still we have noticed or observed a few disadvantages. Now, the thermosiphon cooling is again another system wherein the requirement of additional pump to supply water from that sump into the engine system will not be there. So, having a thermosiphon cooling, we can eliminate the need of additional pump. So, we can reduce the first time or installation cost, but at the same time there will be some sort of disadvantages because we need to rely on the natural circulation. So, if we need to rely on natural circulation, perhaps you have studied in natural convection that we need to have certain height difference, otherwise the efficiency or cooling efficiency will not be that much. So, knowing the advantages and disadvantages of water cooled system, you can really relate that the thermosiphon cooling is kind of extension of water cooling, wherein the need of additional pump to supply water from sump into the engine system will not be there, rather the system will rely on natural circulation loop, and again if it is based on the natural circulation loop, some additional problems or issues will be there. So, if we summarize today's discussion, we have discussed about the lubrication system, then we have discussed about the requirement of lubricants, several types of lubrication system, and then we have talked about the cooling system, which is again an important system for an engine, because we have repeatedly discussed that we need to take away certain amount of heat, but we must be careful when someone is designing or a designer is designing a cooling system. He or she must be careful that that coolant or cooling system won't be able to take away maximum amount of heat, otherwise it will reduce the engine performance. So, with this I stop here today, and we shall discuss next topic in the next class. Thank you.